Hey y'all, it's Jesse with Green Tick. It's going to be a very short video on how we cut a 1911 for an RMSC optic. In this case, it was a Holosun 507K. Generally speaking, I'm a Trigicon fan, but I think that the Holosun is a perfect pairing for the 1911s, mostly due to the integrated rear sight. By milling to a depth of about 5 millimeters, you can still use the factory 0.170 or 0.180 inch tall front sight, and that'll give you a lower quarter co-witness. The ideal sight is actually 0.173, but we're kind of splitting hairs here if we're worried about 3007 inch. If you're wondering if we can cut your 1911 for this setup, the answer is it depends. The 1911 platform is fairly standardized, but some do feature a firing pin safety plunger, whereas others do not. If the sled has a firing pin safety, we can't do this cut as it would mill into the cavity that the plunger sits in. If you're not sure if your sled has a firing pin safety, look at the underside of your slide. If it looks like the picture on the left, you're in luck. Odds are we can cut your slide. If it looks like the picture on the right, that changes things a little bit and we probably can't cut it in-house. We can, however, recommend you to a company that can help you out if you'd like. Just contact us on our website, www.greentickTactical.com, and we'll help you get pointed in the right direction. There should be a link for our website in the description below. And now on to the fun part. The first operation you're looking at is a roughing operation. The purpose of this operation is to clear out as much material as possible, as quickly as possible, so we can get into some of the finer details. With a few exceptions, this operation is done in two passes. The first pass clears out everything down to the top of the indexing bosses, and the next pass will clear out any remaining material between the indexing bosses and the floor of the optic, minus the small amount of material which will be left on the floor for a finishing operation. This particular tool is a 3/8 roughing end mill with about 7/8 of an inch length of cut. Because the RMSC cut is so small, the 3/8 can't get into every nook and cranny, so we use a 6mm end mill to finish what the 3/8 inch couldn't get to. Now that we have the bulk of the material removed, we can start getting into some of the finer detail. What you're looking at here is a 3mm end mill doing a contour operation on the front and back edge of the cut. You may notice that we take several passes, and that's so that we can mitigate deflection. Now, if you're unaware, deflection is when the tool, particularly a small tool like this, is pushed laterally away from the cutting surface. That small amount of deflection, if it's not accounted for, will result in an undersized pocket and an optic that doesn't fit. With the front and the back of the pocket now defined, we can move on to the indexing bosses and screw hole post. First, we contour around each of the posts down to the exact factory specifications. Then, we run the same operation again, but we remove about 2 to 3007 inch of material. This accounts for whatever finishing product is applied after the cut. As I mentioned before, we left a little bit of material on the floor of the cut for a finishing operation. Unlike the roughing operation from earlier, finishing operations employ a very small step over and take quite a while to complete. The result, though, is a nice, smooth, mirror-like surface. At this point, the optic should fit perfectly into the milled pocket, but we still need to drill and tap the screw hole post. You'll see three tools used in this segment. The first is a spot drill, which creates a very shallow pocket for the upcoming drilling operation. You can get away without spot drilling, but you run the risk of the drill bit walking and putting your hole a little bit off of center. The spot drill ensures that the hole is exactly where you want it every single time. If you've ever seen our website or had us do any jobs for you in the past, you probably know that we are huge advocates for using screw hole post on optic cuts. Screw hole posts provide far more radial surface contact, which results in lateral stability and repeatable mounting. However, the most important reason to use screw hole post in this cut in particular is thread engagement. The minimum thread engagement for this particular screw is just under 2.8 millimeters. By using screw hole post, we were able to get just over 3 millimeters of engagement on the ejection port side and 5 millimeters on the other side. Without using screw hole post, you'd only get about 1.4 millimeters of thread engagement, less than half of the minimum. Whatever firearm you're having milled, be sure that the company uses either screw hole post or indexing bosses, preferably both. The last operation that you'll see is what is known as thread milling. When we thread mill, we use a very small tool. In this case, the tool is only 0.08 inches in diameter, to mill a helical pattern on the internal wall of a previously cut hole. As a result, you get a perfect full-depth thread every single time. Once the thread milling was completed, we checked for fit, checked thread engagement, and removed the slide to prepare it for Cerakote. We offer two main categories of options for Cerakote. The first option is to have us apply Cerakote Elite Series in-house. If you're looking for something a little bit more custom than Cerakote Elite Series, we partner with several top-tier Cerakote companies who carry hundreds of different colors and do amazing Cerakote work. We handle all the logistics for you, and we do not charge you anything extra for shipping. I believe this customer was getting a multicam pattern on his slide, and we will add pictures of the finished slide to our website as soon as they are available. If you have any questions, please feel free to reach out to us on our website, www.greenticktactical.com, or just leave a comment in the comment section below. Thank you for taking the time to watch this video, and have a great day.